Hello, hello.
There we go. Okay.
I'm using a very old laptop.
Okay.
Yeah, sorry. I thought my mic was on. I might have tried to say a few things. I met my PhD advisor at NeuroSim in 2003,
Okay.
and yes, it was a very different conference. but funnily, yeah, it's always had a skiing. I mean, it wasn't just at the conferences in Vancouver, but then the workshops were at Whistler.
Okay.
So it was the skiing, you know. And then they'd have workshops like early morning, and then there'd be a really long break, and then they'd have some workshops in the afternoon. Yeah. So yeah, I just wanted to talk about agentic coding, just because it is super it's very relevant right now. I liked Daring Fireball, which is a very old macOS blog, has a nice claim chowder recurring segment, and I think the claim chowder yesterday was the Anthropic CEO from a year ago saying that 100% of code written was going to be AI generated a year from now.
Yeah.
that was last year. But at the same time, there is some remarkable abilities here, and like I've said, if Lady Ada is using OpenClaw to generate firmware in her hardware projects, like there's something there. So she's talking about, for her, it's the need for, she just was on maternity leave and she had this like huge backlog of devices that were kind of waiting for her to work on, so that she could sell these things. And part of getting them ready is getting various firmware bits written. And anyway, she's just like look at this massive stack of technical documents that I'm supposed to go through and process and get ready. And because of maternity leave, it's like 10 times higher than it would normally. But by leaving OpenClaw, she's just installed on a Raspberry Pi in a loop. It's just crunching through all this documentation and producing all these things in iteratively, and like she loves the output. Like she's had to restore the Raspberry Pi system from time to time, but it's safe. She's been then doing end-to-end testing the same way she would if she was hand writing things, and anyway, so I'm doing a fellowship right now on agentic coding as a way to really familiarize myself with the tools, and just want to talk about some of the things that I've been doing and how I've actually been, like totally agree with everything that you started with, you Sarah and Bradley, about the difficulties of dealing with AI generated PRs and the care which we should the extra care we should take with them, myself included. And I can talk about one of the funny things I had submitting a PR as well. So let me just see if AV. Sorry, just remembering my. Okay. So the other thing being that this entire presentation, now, do I have to not see you? I guess I do. So 1 second, sorry. I also haven't used a Mac in a really long time. So, okay, here we go. Okay, so, the other thing about this particular presentation is that I asked Claude to generate me a Beamer presentation. It's auto scrolling for me. So I asked it to create me a Beamer slide presentation of all this work, just by going into each of the repos that I was working on and actually grabbing, basing it off of markdown files that it had used as at the research stage, right? So this is the other kind of nuts thing to me, is that I did not touch any LaTeX in terms of generating this. And again, as someone who had to who's written many documents in LaTeX, that's also pretty funny. So just going to talk today about, if I can get the slides to go forward, going to talk through a bunch of different projects. I'm going to tell you about how these are all connected, but you'll recognize that there's a bunch of topics here that we cover kind of regularly in at the lab, and as we I've always been interested to find a pithy way of describing orthogonal. But I think a modern natural philosophy group was the one I settled on. But in this case, again, this is all written by Claude. Okay, so Claude took the scope of the projects that I was working on and decided on this particular title, which I think is interesting. Now, these are again what it could see across the kind of topics that we're going to talk about. But as probably for the students, I should just say that the kind of work I do is psychiatric neuroimaging. So I'm usually, can you see my cursor, Bradley?
Yes.
Yeah. Okay. Thank you. So I'm usually working at the neural dynamics. So looking at brain imaging data, and a lot of people who come to the free energy principle from philosophy, cognitive science discussions don't really realize that this is actually Carl's main focus was processing, being the analysis lead at the functional imaging lab for 35 years. So a lot of the work that we do and the implementation and the software that we have is around variational bays of neural data. Yeah. But I'm going to talk about how what else we've been connecting that to. So again, this is not fully written by me, so it's just connected a bunch of different software projects. But one thing I think is the next one, yeah. So So I want to just talk about why I chose to work on Patrick Kidger's JAX scientific ML and JAX stack. So Patrick was a student at Oxford, like back in the like 2018 to 2022, something like that. He wrote his thesis on neural differential equations in ML, and he had as part of his thesis this philosophy that that has made it into most of the science, the JAX tools that he went on to develop at Google, DeepMind. And this is this composable differentiable primitives. And what that allows you to do when you also have this auto differentiation that is a part of the kind of modern scientific ML software that we get. So um, I'm gonna be exploiting a lot of these, as well as like my particular project is to fill in one of those gaps, fill in a couple of these gaps that that exist in the current JAX stack that are directly relevant to the to DivaWorm and to some extent to Sustain Hub. But yeah, anyway. So obviously for DivaWorm, one of the things was hypergraphs, and that was what I made as the kind of first project, which was definitely like trying to create a native library that would get to the point where I could actually submit it, like talk about it in public spaces, get feedback on it, and try to, actually start a new open source project that is a real contribution for the computational science community. and the way in which I'm doing it is like I'm and of course Claude is doing it, right. This is I keep the everything that's produced has got the little Claude, I forget what their um, footer is, but it's this is co-created with Claude or something like that. But the important thing being that I'm not just going to have Claude write this, but I'm going to use particular data sets, and I'll show you later in terms of being able to load some new data that that I can test against existing implementations that I'm drawing from some R packages. So this is where this is how I'm kind of end to end testing it. In that, I've taken this particular organoids developmental regulome paper that I've talked about previously, and this R package, Pando, and I'm replicating the analysis using the data from this multi-omic data set, to be able to both replicate what was done previously, as well as because I'm part of this JAX stack that allows me to actually do things that the Pando, the particular package that they used, just wasn't able to do. And to be able to do that with very concise, very readable code, actually, which is, again, is one of the, I want to say is one of the design considerations here, is that I want to actually end up with something that is to some degree human readable. And part of that is to make like software library choices and kind of software architecture choices that permit that kind of um, concise code. Anyway, so I moved on, and this actually came out of working with the Sustain Hub, but I, in this particular case, one of the ways in which I've been trying to kind of maximize um, the agentic coding's productivity is to not necessarily write new code. So I go through an extensive planning stage with a lot of background research and of course feeding the agents a lot of like my domain knowledge about places to look, researchers to be familiar with, and projects to learn from. And so in this case, I'm actually just extending. I didn't see the need to actually create a new package, and it would have been much harder. But to actually take a DeepMind package called PG Max and to build with it this probabilistic factor graph package, to build with it the additional functionality for active inference that features that I wanted to have for a particular variant of Sustain Hub that I was going to generate. So again, this is drawn. Claude wrote this, so I think it's one of the Markdown files it created. It had this in the yeah, it does. So this is the like I said, this is what I took from DeepMind to actually use as a base, and then I just extended with the particular design goals that I had for the active inference functionality that I wanted to add to the agents that I had in my version of Sustain Hub. Now, it's not doing things in the right order because I haven't talked to you about Concordia. So I'm hoping it's going to say no, it's not. So I should just say that Concordia is another DeepMind project that is focused on generative agent-based modeling. It's using LLMs, and is something that they did a 2024 contest for in terms of doing kind of multi-agent, multi-turn LLM simulations. So I can say more about that later, but it's I was just kind of using it to replicate some of the earlier LLM-based models of the open source sustainability project. and then in this particular case, I'm giving those agents kind of more autonomy with this active inference features. So I'm going to skip through this because it's obviously this is more interesting to me, but it's not really relevant to the. It's not fully relevant, except you'll see that there is at a program, at a code implementation level, there's a lot of overlap between these projects, even though they're at very different scales. But they'll have common mathematical foundations. So again, I'm trying to identify these important these gaps in the scientific ML code space in Jack's ecosystem, at least, that actually are very helpful at kind of multiple scales, multiple scenarios. and this is actually one that's kind of important to me, but not really important for the Next week, this is definitely more relates to my particular academic work, where I focus on structural MRI in psychiatric populations. But next week is the DiPi conference, and so that's the diffusion in Python online conference. It's hosted in Indiana. Great group there. And on the 18th, they're going to have a special meeting as a part of the conference where we're actually talking specifically about the role of AI tools in scientific software development, right? And my example is going to come from this DMI version that I've refactored with JAX because it's so this is diffusion microstructural imaging in Python, and it is a way to do physics modeling of the diffusion data that the JAX refactoring that I've done has actually been really, really powerful in opening up, enabling new a new analysis of older data sets because of the superior optimization that I get from some of the neural differential equations and physics informed neural networks that I've kind of easily enabled from adopting this stack and replacing the old SciPy code. So this DMI Pi was like a PhD thesis from a group I know and back in France, but it's like 7 years ago. But they did a really great job of kind of building up. Their code was very well structured, and it made for a very simple JAX refactor with a lot of built-in software tests for me to just replicate against the old code. And I'm going to come back to this particular topic and how it relates to open source. So Concordia is that social simulation software I was talking about. So I've been making this adaptation, my own adaptation of the Sustain Hub, using Concordia and trying to add some additional features to it as it relates to both giving agents more autonomy, as well as talking about some of the governance issues. So this is something that is the meeting that the event today is called Funding the Commons, and it's a lot about how governance can improve the collaboration and those kinds of pro social features. But I know I've gone through a lot of code just to say this is the kind of comparison that I've been doing, taking the RL through to the active inference and like more social dynamics that I'm able to kind of easily add with Concordia to do some comparisons. And again, I'm going to share all this codes on my GitHub. So with Concordia, I've actually added a second simulation that's based on another archive paper, but I know it's I've been talking a long time, so just wanted to get to that that there is enough that if people want to play with the hypergraph neural network, certainly the hypergraph library, and do JAX work, you can do that together with get together with the tools that I've got here in this Divograph uh, edition. And then the last thing I've been working on is trying to follow Danny Bassett's work. Um, and this is the second kind of missing mathematical foundation library that seemed to be important for the kinds of especially the kind of interventions that we're interested in psychiatry. So we do a lot of connectomics, looking across the brain to find networks, and but being able to really understand how to modify those or make interventions is the real goal. And yeah, so she's been a real they've been a real pioneer in pushing this in neuroimaging. And it actually is nice because it does come back to actually having some it's relevant for what we've done with the hypergraphs. So this is the latest project. So I don't have any tests of this yet. It literally was finishing up last night. So anyway, but I'm really, like there are no tools for this, no open source tools for this in any of the packages that I know about. And so I'm really excited to try and find good tests for this if anybody knows any or can suggest any. But like I said, I don't want this, if we're not able to kind of bring this back to something that Jeremy Howard, who was an early pioneer of AI, but is also a real educator. And if AI is not teaching us, then then it is not a net positive. So certainly one of the other things that I'm trying to think about here is how to use these tools as a way to actually better understand the material, as well as there is an opportunity when you're generating software to actually be generating, it's an actual it's an implementation of math that can some degree can be its own documentation. What I was taking some um, uh, inspiration from, I think it was Newth who did literate programming. Is that right, Bradley? Anyway, you know, it's something that I used to do in LaTeX, is that you could embed your R in your LaTeX, so your visualization and your text are all together, and it's kind of a way to so you usually be using LaTeX because you also have math equations in there. um, what I'm asking the tools to do is to also be generating um, generating you know code examples, as well as some Jupyter notebooks to explain the connections between the functions that we're generating, and in this case was asking for Claude to give me the historical context of both the history of animal behavior and its mathematical modeling, together with the history of reinforcement learning and its mathematical modeling. And so I was definitely more modeling this on spinning up in RL, but I'm very aware of kind of like the pre-course material for Neuromatch Academy, and trying to generate something that's uh, that can be as kind of comprehensive as the diffusion microstructural imaging material that I've already got. So these are this is going to be the kind of the tracks. Oh, sorry. You know what this is missing is the um, Ryan Smith's tutorial in um, tutorial in active inference is actually a bigger uh, um, inspiration for this particular, and part of that is obviously also replacing all his MATLAB examples. So, um, excuse me. I've been doing this at the lab. I've definitely been learning about um, how to. It's been interesting to see the issues around LLMs when I actually have to make my own server for them. Versus, I've got some projects where I'm using, pay as you go, and so this is nice to actually have my own DGX to so I don't have the rate limitations that they a lot of the companies provide. Um, yeah, so this is the kind of the unifying vision here, and I these are the I hope you can somewhat see why a lot of these are connected to each other in terms of the kind of the, the different applications, but at the same time there being some real overlap, and that this is it's a core set of mathematical tools that actually have a wide set of applications. And yeah, like I said, you can see the work I've been doing. um, Check us out on GitHub. All the repositories are on my GitHub there, and you can see some of the things that I'm working on. I'm not actually doing a proposal myself, but again, this is all written by Claude. and But I certainly hope it's useful for students that are getting into this work. And yeah, thank you.